So I want to show you a review of the PicoScope 5000 series device. So this is a 5444B, 200 megahertz analog bandwidth. Comes in a little box, USB quick start guide, other stuff. It tells you this device you can actually power by USB if you want, if you just have one or two active channels. If you have 3 or 4, you have to use the DC adapter. I always just use the DC adapter, it's just easier. So let's take a look at the scope itself first. So here we have this is as I said, a 4-channel device. So we have the 4 input channels, your standard probe compensation measurement here. What I really like here is that there's these 2 additional channels. So this is the external trigger in and the signal generator are right on the front here next to everything else. So if you have this down, everything you need is here. On the back side, we just have USB 2.0 and your power supply. And if you want an earth, you have that. So the external trigger input you can use if, for example, you're using all 4 channels and you need another channel for trigger, you can use that. It's also useful, any of these USB scopes have the maximum sample rate, a gigasample per second, you only get on a single channel. So one channel will give you a gigasample per second. As you start to enable more channels, it reduces the sample rate. If you need a gigasample per second, but you need a second channel to trigger on, you can use the external trigger. And so, for example, you can know from the specific point a rising edge on this channel happened, what the time reference is on the A channel measured at a gigasample per second. This device also has some really interesting technology that lets you switch the input resolution. So if you're using all 4 channels, 8-bit resolution, this is what most scopes tend to have. But you can also switch it to 12-bit resolution on all of the channels, but at a slightly reduced sample rate, I believe. Or you can do stuff like switch if you just need one channel, you can actually get 16 bits. Which is extremely high resolution, at a reduced, I believe, 62.5 megasample per second instead of 1 gigasample per second. But there's a lot of times where you run into, you could use the extra bits and you don't care about the maximum sample rate. Other times you really do need the maximum sample rate and 8 bits is fine. So it's nice that you can switch this and you don't need to buy different devices for different scenarios. And it's important to realize the actual ADC itself inside this is sampling at a higher resolution. It's not a case of doing it in software with filtering. All of these devices, any of the Pico, any other manufacturers have a software enhanced resolution. They could give it different names, but that's not what it's doing. Anyway, let's keep going in the box here. To the side. So we have the power adapter here, just a little small one, which is nice, about USB hub size. They give you the tips for whatever country you may happen to be in, including a friend, the E-blog guy in Australia will be happy to see. And they give you a number of scope probes, so we'll just pull one of them out. There's 4 of them in here, obviously. So these are more or less your standard scope probes. If you look at the PS5000 review, I rave about the PS5000 scope probes. Are really nice because they're spring-loaded. These guys are just your standard ones, so normal tip here, normal type of grabby thing, and you can switch it between 1 times and 10 times. As always, be very careful. If you're in 1 times mode, you might not realize it, but your bandwidth is very limited. So here's the little sheet that comes with it. So in 1-to-1 mode, you have a 10 megahertz input bandwidth. In 10-to-1 mode, you have a 250 megahertz input bandwidth. So most of the time, you really need to use that 10-to-1 mode. Unless you're doing very low frequency stuff, the 1-to-1 mode isn't of much use for you. All right, so let's move this out of the way. Let's power everything on. Actually, before I do that, I want to make a few notes about the USB scopes. Do you get a USB-based scope or not? Or should you just get a regular old benchtop scope. Then this is very personal. I prefer the USB based ones. You can mount them anywhere. My old scope, which was the TiPi parallel port scope, I had mounted under my desk, and that way it was always out of the way, and I could just connect probes to it. Something like this, you can easily mount sideways somewhere, mount out underneath something, whatever you want to do. I really like that, and you also have less to break because there's just this box. I just spent the other day fixing a huge benchtop scope that was Windows XP based, Agilent one, and the DDR, the memory sticks had failed on. There's also hard drives in some of those ones. Those are really big ones. But even a normal, smaller, low-cost benchtop scope now has LCD panels, whatnot to break. So that's just personal. Some people prefer to have the LCD, separate and everything like that. I really do like having it on my computer. Another complaint is that you don't have knobs with these. That's something you can fix with. I made this little USB-based knob board, so it has just a whole bunch of knobs for setting stuff like the offset and the voltage range, time base, and all it does is it emulates a USB keyboard, which in the PicoScope software, or whatever other software, you could use this with anything. You just map those keystrokes to increase, decrease voltage or voltage range or whatever you want, and it's just USB. So I have details if you want to build one of these that are of interest. One other thing, I originally had marked this as a con when I was doing the review, but I started to test some other scopes I had, and that's that all of these scopes, obviously the inputs, the grounds of them are not isolated, they're all connected together. Get a good here, there you go. And also they're connected to the USB ground itself. So if I do there and connect USB, you see there's a connection there. But I started measuring on full-size scopes, and all of those guys have these inputs connected to earth ground through the plug. So is there an advantage? I don't know. I don't really think so, because you're always ending up with this ground connected to something, and you have to be careful you don't connect this ground to have a voltage difference between it and the board you're measuring. These guys might even have a bit of an advantage, because if you want, you could of course just this 5-volt supply is your typical switching supply, which is isolated. And all you have to do is float your laptop, so you could leave your laptop either unplugged. Your laptop itself might not be referenced to earth ground. And at the end of the day, it's a lot easier to float just that little device rather than needing like an isolation transformer or something, which is getting crazy. I haven't tested some of the other ones, like the Rigel devices. I don't know, maybe they are isolated from earth ground, so I can't say specifically if they are or aren't. But it's just something, don't be too hard on them just because the USB negative is connected. As far as I can tell, that's not too uncommon that something is connected between these negatives, so you have to be careful. Anyway, plug that in so you get a little light that goes on. What's cool is that when you unplug it, it seems to turn itself off, so you can just sort of leave it plugged in and plug into your laptop when needed. So let me turn this off. I want to point out, I'm not going to go through a full detail of all the features of it, because I posted a review and I talk about a lot of the different features in much more detail. I also talk about the this 8-bit, 12-bit mode, what it means, and there's some examples in the PS6000 of stuff like using the digital decoding, which is really cool. So if you are interested in these, you can look up that for more details. But let me just fire up the PicoScope software. Alright, so connects up, and more or less what you expect. So turn this on here, and I don't know, let's put the probe compensation. Or actually, let's do more fun than that. So I'll put it in 10-to-1 mode, and I'll put it into the signal generator. So just so you can see, let me show you. So there we go. So I have a probe, bam, into the signal generator. Easy. So we need to do a few things. First, I'm going to tell it that I'm using a 10-to-1 probe, just so it scales everything properly. And then I'm going to enable the signal generator. So this model has a full arbitrary waveform generator, which I actually really like this because you can do stuff like record from measured traces and then output that. And you can even use that to modify things a bit. So I have an example where I show you recording serial data and then playing it back at different bit rates to check, if you're writing in a software UART, you want to know how much leeway do you have on the speed of the bit rate. So I'm not going to do that right now. I'm just going to keep it running on the square wave. That is good enough, but let's go to a higher frequency. Let's say 1 megahertz. And see what happens. So what I'm going to need to do is, obviously I need to increase my, too much. Resolution. So there we go. There's the square wave. There's a bit of ringing, presumably because it's not terminated properly. But you get the general idea of it. So let's switch to a auto. So this is your standard 8-bit resolution. So this is, I want to point out that, again, there is this resolution enhancement, and this is something most scopes have. They call it different names, but this artificially lets you increase the effective resolution. It's typically doing this, or I think always doing it, through filtering. So you have to be careful because it's actually, you can see here as I go to, say, 12 bits, it's changed the waveform quite a bit. So it's doing more than just increasing the bit rate, and there's sort of nothing you can do about that. Whereas this is actually saying I can increase the rate that the hardware is sampling, or there's the bit rate the hardware is sampling at. You'll notice there's limits, so I have one channel on 12 bits, I'm now at 500 megasamples per second. If I go to 14 bits, it's going to limit that again to 125 megasamples per second. But what makes this really handy is that you do run into scenarios, and fairly typically, where say I had a huge spike here that went up to 10 volts, and I need this plus minus 10 volt range. If I was just limited to 8 bits, we can see right away there, you can see the quantization error, not error, but just the quantization, because the system's limited. I'm forced to use a plus minus 10 volt range. If I was plus minus 2, it wouldn't look nearly so bad. Zoom out. But in this case, I'm saying, well, there was another spike here. I have an example of this. I use, in the example, I'm testing a power supply, which gives me this larger spike I need to verify. You switch to 14 bits, for example, and all of a sudden you can zoom way in and you're getting much nicer looking signal. Of course, you can go all the way up to 16 bits. When I go to 16 bits, you'll see that the sample rate's going down even further. So there is some trade-off. So now we're not seeing as much detail about the spikes. So it is nice. I mean, I do like the fact that you're not just going between, say, 8 bits and 16 bits. You can increase slowly just to make sure that you're not losing information. So you can make sure, okay, there's no spikes, no very short spikes I get at a gigasample that I don't get at 62.5 megasamples per second. The other thing of interest is FFTs. And in FFT mode, this is actually cool. You still get this option of increasing the number of bits. I have a video where I show you the importance of this. Fundamentally, the quantization error of using 8 bits will introduce some errors into the FFT, just theoretically, not even due to any specific hardware stuff. Whereas when you go to 16 bits, you should see a cleaner signal. So here, let's do that again. So if I go from 8 bits here, compared to 16 bits, we can see the noise floor is dropping way down, which is due to various effects. One of them may be the The sample rate itself is changing, although you can see the sample rate here is 31.25 in both of these. So it's primarily due to the improved quantization that the noise floor is way better on the FFTs. So having, again, that flexible resolution is a huge improvement here. One other thing I mentioned in the my PS5000 review of doing FFTs is one thing you'll often see is the length of the FFT, and do you care about that? You probably do. Some scopes will have less. They'll have something like 2048 points, which may seem okay. The problem with the FFT is you're always starting at 0 megahertz and going up to whatever frequency of interest, in this case 16 megahertz. So if I only cared about 8 megahertz here, when I zoom in, this is I no longer have those 2048 points. I only have a small subset of that around the frequency of interest. The longer FFT is probably primarily of interest because it means that when you zoom in, you can still get, and because the FFT length changed, when you zoom in, you now get a lot more resolution on the specific signal of interest. So here you could see, for example, if I was worried about is there one, is there multiple, you can learn that information. So let's turn on something more interesting. So here's a square wave. There we go. Just zoom out all the way. Oops. Okay. So there's a square wave, and there I'm using a fairly long length FFT, so I get the frequency resolution. If I had a shorter length FFT, I wouldn't necessarily get such good frequency resolution, especially as you're zooming in. There is some other interesting features that I look at the specific videos if you want to see, for example, serial decoding, and this is really handy, especially because it gives you a bunch of protocols, I2C, RS-232, all, you don't have to pay for any of them, and it just shows up in the analog view, so it's quite handy, I think. Anyway, I hope this was a little bit useful. I was just trying to show you a bit about the PS5000, so I don't have a real, I'm not making money off you buying them, so if you have questions, you can feel free to ask in the comments or whatever, and you can check out the review. I was just trying to show you a few details that when I was looking at a scope, some questions I had around what do these devices do, what's their performance like. In the review, I also compare some of them to a few Agilent scopes that I had in the lab at school. So, hope you enjoyed this.